So today what we're going to be doing is we're going to be doing some more advanced sets of equations with parentheses. The idea is that we're introducing this idea called nested parentheses or nesting parentheses. And that's the idea that we may see parentheses like later on the sheet where we have them nested inside of each other. I have a parenthesis inside a set of parentheses. And the idea behind how we're going to solve them is because of the idea of PEMDAS. The idea of PEMDAS is every time we see a set of parentheses, we restart the PEMDAS cycle. So I go inside a set of parentheses and I go through the set of operations. If I see another one, I restart and go through it a second time. So let's go ahead and get started. Where we last left off is we had a set of equations with a singular set of parentheses. And if we remember, the single set of parentheses means that we have to multiply everything on the inside times that single thing on the outside. So the 4 gets multiplied by the x and by the 3. So x gets multiplied by 4 becomes 4x. The 3 gets multiplied by the 4 and it becomes a 12. After that point, we just go ahead and isolate the x like we've always isolated. And the way we do that is we go ahead and we subtract 12 from both sides, which is going to give us 4x is equal to 8. And the next thing we're going to do is isolate that x one more time by dividing each side by 4. That's going to cancel out the times 4, so we'll get x equals 2. Perfect. Now that works the same with one set of parentheses or with two. Regardless of what's going on, we're going to take everything on the inside and multiply it times everything on the outside. So each one of these terms gets multiplied times 5. All distribution means is we multiply more than once. So I'm going to multiply this 5 more than once. Boop, boop. Let's see, 3 times 5 is 15, and 2 times 5 is 10. I'm going to multiply this 5 more than once. So 5 times 1 is 5. 5 times 12 is 60. Perfect. And the next thing I'm going to do is I want to combine these two x terms, which means I need to get rid of one of them. I only want x on one side of the equation. So I'm going to get rid of this x by subtracting. Subtract 5x, that goes away. Left with 10x plus 10 is equal to 60. And then I do the same thing with these two constant terms. I want to get rid of this 10, so how do I get rid of this 10? Well, I subtract it. And what ends up happening is I have a 10x equals 50. So now that I've moved all my x's to the left, I've gotten rid of all the x's over here, and I've gotten rid of all the numbers over here, so all that I have is an x and a number. Now I get rid of how the x is connected. We do that by division. So in this case, I get x equals 5. Oh. And so if you wanted to see one more of those in action, try pausing the video here, going through the same steps that we had above, and see if you can't get to the answer. Okay. Let's take a look and see how we did. I'm going to multiply this 5 more than once and this 2 more than once, because that's what distribution means. 15x plus 20 is 10x plus 40. Now I have an x over here and an x over here. I want to get rid of my x's on the right, so I'm going to subtract it. I'm left with 5x plus 20 is equal to 40. Next, I want to get rid of my numbers on the left. I'm going to subtract 20. It's going to get rid of that. So I have 5x is equal to 20. My last step is I'm going to go ahead and get rid of that coefficient. That coefficient is connected to the x via multiplication, which I know I undo via the division operation. And I get x equals 4. Oh. So we can all agree that even when there's more than one set of parentheses, if they are horizontal in nature, meaning they're not nested, we just distribute the outside terms and we continue to solve per normal. But what happens if we have a nested set? So one of the things that we're going to notice is that this first set of parentheses is completely and totally inside the other set of parentheses. And so I'm going to color code these so that we can see them a little bit better. Now this is a very introductory type of nesting parentheses, but I think the parallel that we can draw works. So there's several ways to solve this. I'm going to teach the inside out method, which means I'm going to go to the innermost set of parentheses and slowly work my way outside. Are there easier methods to do this? Probably. But this method, again, when we get more complicated sets of parentheses, will always work. So let's go ahead and let's take a look at this. I'm going to go inside this set. So normally I would distribute 3 times everything inside, but I noticed that I have this thing. So I'm going to go in one more layer and say I'm going to multiply 6 times everything inside. So 6 gets multiplied times x, and 6 gets multiplied times 6. So quite literally, I'm just distributing the first thing. So I still have a 3, but in this case I have a 6x plus 36. And remember, all we did was we distributed that inside set of parentheses. I still have the outside set. So I distribute the 6 times both those terms and I get that. I still have the leftover 3 on the outside, which means I have to distribute a second time. So that's going to give me 18x plus 36 times 3, 8. Oh yeah, it is 108. 108. That's a 1 if you believe it. Okay. And so what we're going to do is I'm going to subtract my 108. Get rid of that. And I have an 18x is equal to 180. Go ahead, divide both sides by 18. And I get an x is equal to 10. So we can see that nested parentheses aren't really a big deal. You just take the innermost set of parentheses and do whatever distribution is necessary, and slowly work your way outside. So, using that as an example, go ahead and pause the video right here, see if you can't knock out that one, and then check your work. Okay, so let's see how we're doing. So I know that we go to the inside most, which means I'm going to have to distribute this 2 first. So my 3 remains unchanged. 2 times 5 is going to give me a 10, and 2 times 25 is going to give me a 50. And then as I work my way out, I get 30x plus 150 is equal to 0. Now that I've cleared all sets of parentheses, I'm going to go down, I'm going to start solving for my variable, which means I need to remove this 150 over here. And once my x term is completely isolated, I get rid of the coefficient by undoing that set of multiplication with division. So I get x is equal to negative 5. Perfect. And so nesting parentheses can have more than just whole numbers. We might have to deal with fractions. So here's our first foray into fractions. Go ahead and see if you can't solve this one by pausing the video. Okay. Let's see how we did. I'm going to distribute this 1/2, leaving the 3 unaffected. So 1/2 of 12 is 6, and half of 8 is 4. I can also, over here, because this is a different set of parentheses, unconnected to these, I can go ahead and distribute those. So left with a 12x minus 24. And now I have this, of which I'm going to distribute again over here. So I'm going to multiply both those terms by 3. 10x minus 12. Okay. And now I want to get rid of this 12x on the right so that all that I have left is x's on the left. I'm going to do that by subtraction. Perfect. I'm going to get rid of the minus 12 by adding 12 on the left, which is going to move that away from the 6x. And then my final step right here is I'm going to go ahead and divide by 6, which is going to lead me to a final answer of x is equal to negative 2. Boom. And there we go. So today what we're going to be dealing with are advanced parenthesis equations. This is no different than what we've been doing, but it's going to have several times where we distribute and don't distribute all in the same equation. So let's go ahead, let's not waste any time, and let's get started. So when we deal with a set of parentheses, remember, the main thing is we are multiplying everything inside the parentheses by what's immediately outside. The 2 is immediately outside because it is directly connected. It is what we are going to multiply everything in this equation by. The 8 is not, because it is separated by an operation that says it is something else. So I'm only multiplying everything by 2. I'm not adding 8 to everything. So I have a 4x plus 10 plus 8. I should do that in black. So 4x plus 10 plus 8 is 30. Now, the second thing we notice is that when we're combining terms, both these 10s and these 8s are on the left-hand side of the equation. So I'm going to treat it like an expression. What is 10 plus 8? Well, in that case, that's 18. And this is what we call combining like terms. So 4x plus 18 is 30. And when we get to this point, this is the normal solving for equations. We isolate the term by getting rid of 18. We're left with a 4x equals 12. And then we get rid of the coefficient. And we know that coefficient's attached via multiplication, and so we divide it away. And we're left with an x equals 3. Perfect. So the next one solved the exact same way. So go ahead, pause the video real quick, and see if you can get that done. Okay, let's see what we did. Now with this one, remember, we distribute what's immediately outside, and not to that 25, because the 25 is separated with a different sign. So we're going to get a 5x minus 10 minus 25 is negative 40. Again, just like the prior question, I see that I have two terms on the same side, so I'm going to treat it like what is negative 10 minus 25. And I'm going to get a negative 35. Then I go through the process of isolating the term, getting rid of this 35 over here. I got to add something over there to balance it out. I have 5x is equal to negative 5. And then I get rid of the coefficient. I know that's attached via multiplication, so I undo that with division. And I get x equals negative 1. There we go. Not too bad. Now, the next question you might ask is, how does it work with a variable instead of just a constant? Well, nothing really too much is different. We're going to distribute just like we always do. 3 gets multiplied in. So 3x minus 6 minus 2x is 3 minus 2x. That's an x if you believe it. The next thing I notice is that unlike up here where the two terms are side by side, these are still on the same side, but they're separated. So I can look at what is 3 minus 2x. Think of it as though you could just cover up that negative 6. What is 3x minus 2x? Well, that'd be 1x. And generally we show this in my history is we're going to underline the like terms so that we can say, hey, these two things are going to combine into a 1x. minus 6 is 3 minus 2x. Now you don't really need to put the 1. I just wanted to put the 1 so we could see that that is what we did. Now our next step, because I want to get rid of one of these x's, either get rid of this one or get rid of this one, we're going to have to move it across. So I'm going to get rid of this one over here by adding a 2x. And remember, I need to keep both sides balanced, so I'm going to add a 2x over here. So 3x minus 6 is 3. And then just like the prior two questions, isolate the term by getting rid of this thing. And then isolate the variable by undoing that multiplication. And so you get an x equals 3. Perfect. So now that you've seen one of those in action, go ahead and try one on your own. Pause the video, see what you can get done. Okay, let's take a look. Just like the prior one, we distribute what's outside the parentheses, what's immediately outside. So that becomes a 5x plus 15 minus 3 equals x plus 20. Okay. In this case, I notice that I have a 15 and a negative 3. So I'm going to say, what is 15 minus 3? That's going to give me a 12. I'm dropping my pencil. 5x plus 12 is x plus 20. And if I want to get rid of one of these x's, I'm going to go ahead and subtract an x. And now be careful. One of the common mistakes I see is that students will write, well, 5x minus x is 5, because they mistakenly just get rid of the x, because it looks like I'm just subtracting x. But let's not forget that there's that imaginary 1 sitting right out there in front of it. So I'm actually saying, what is 5 minus 1? 4. And then just like our previous examples, I'm going to get rid of that term by subtracting it away. And then my last step is I get rid of the coefficient. I get rid of that multiplication by dividing. And what that's going to give me is that's going to give me an x is equal to 2. So that's all fun and games. Let's try some nested advanced ones. Now, with nested equations, one of the things that we have to remember is that we go inside one set of parentheses and we ignore what's outside for the time being. I'm going to say, hey, I'm only dealing with what's inside here in the red box, what's inside this first set of parentheses. And what I notice is that I can do some stuff inside. So 3x minus 6 that's still inside this set of parentheses. So you notice all I did was worked inside and said, okay, I'm going to distribute this 3. Boom. I haven't touched the outside 3 just yet. I'm going to go ahead and combine those terms. So I have a 3, 3x minus 5. Boom. And so now I've simplified the inside set of parentheses. I've simplified the inside of the nest. And then after I've simplified the inside, I work my way out. Working your way out is just as easy as working your way in. Distribute, isolate the term, get rid of the number. It's going to give you a 9x is equal to negative 18. Once you've isolated the term, get rid of the coefficient by dividing that away. X is equal to negative 2. Perfect. So now that you've seen a nested example, go ahead and pause the video, see if you can't try the last one on your own. Okay. Let's see how you did. So just like prior, I'm going to look inside my nest and say, what can I do? And I know I'm going to distribute. I'm going to get a 2, 5x plus 25 plus 10. And still only looking inside my nest, I'm going to notice that I have two numbers, a 25 and a 10. I'm going to go ahead and combine those. And now that I've fully simplified my nest, now I can work my way out of the nest. 10x plus 70 is 150. And once you've fully worked your way out of the nest, isolate the variable, or isolate the term. 10x equals 80. And then the last step is get rid of that coefficient by dividing it away. Boom. And there we go. So today what we're going to be going over is nested exponents. And the idea behind what we're doing today is that we're going to have things nested inside of a power, and how do we handle that? And the goal today is going to work from the outside in. And this is based off the idea of we're reversing PEMDAS, so PEMDAS. Normally with PEMDAS we go forward. And today, when we undo processes like this, I think it's very helpful to look at it from the lens that we are going backwards and we're slowly moving things away from the variable. And so let's go ahead and set up an example of what we would do over here is if I wanted to solve for what's on the left. Now, let's assume some value of like x equals 10. And we're plugging that in here. X does not equal 10. But let's see how we would solve it. So I would say 3 times 10 squared. So our first step following down PEMDAS is to go inside the parentheses, and inside the parentheses I would multiply. So I would multiply 3 times x. So I'd multiply times 3, and I would get 30. And then the next thing I do is I would power this to the 2. And I would get 30 times 30 is going to be 900. And like I said, that's the way we would normally go it. When we solve this, we're going to be going in reverse. So the opposite of a power is we are actually going to root to this. And when we look at this equation, we see the fact that the root is on the farthest outside aspect of the equation. So we're actually going to square root both sides, which is going to leave us to a 3x, and the square root of 81 is a positive or a negative 9. And now what's going to happen here is I'm actually going to split my equation into 3x equals 9 and 3x equals negative 9. I actually split it into two separate equations to work on their own. And so after I rooted the 2, I multiplied by 3 in this step, and if I look over here, the opposite of multiplication is division. I would divide by 3, which is the final step of isolating that x. So now what I'm going to do is I'm going to go ahead and divide this by 3 and divide that by 3, which is going to leave me with an x equals 3 and an x equals negative 3. So I have two answers to that equation. And that works on any of these. If you're ever asking yourself, how do I solve this? Just make up a value for x and say, well, let's say x equals 2. Does not equal 2, but plug in 2 and see how you would solve it. So 3, 2 squared. Well, first what I would do is I'd do the power and say, okay, so 3 times 4. And then I'd multiply by 2. So 12. And so to undo, to isolate that x that's all the way buried in there, I would just invert this and say, okay, cool. Let's divide by 2. Why did I say times 2? It's by 3. We're going to divide everything by 3. So let's set up my bar. If I divide this side by 3 and divide this side by 3, I get an x squared equals 49. We also notice the difference between the fact that the 3 is on the outside of the parentheses and the 3 is on the inside of the parentheses. So the 3 is vulnerable right here for us to get rid of. Inside, that square power is protecting it. And then the next thing I do is I root, because the opposite of power is root. And what's going to happen here is I'm actually going to split my equation into an x equals positive 7 and an x equals negative 7. Boom, and there we go. And that's going to be the story of how we solve pretty much any of these. Is plug in some random value for, in this case, h. So let's say h is equal to 10 again. Actually, I'm going to make, yeah, h is equal to 10. So I have 10 minus 12 squared. Well, my first step is to go inside and subtract. So 10 minus 12 is going to give me negative 2. So I subtract 12. And then I'm going to power 2, which is going to give me a 4. So I know that reversing my way, I'm going to root 2. And I know what's going on here is I have h minus 12 is equal to, actually let me do this in black, h minus 12 is equal to positive or negative 15. And I know with this, it's going to end up creating two separate values. I have an h minus 12 is the positive 15, and I have the h minus 12 is the negative 15. And so as we saw from here, I would add my 12 because that is the opposite of what we did right here. So I'd add my 12. Add 12. And so I get h on this side is equal to 27. H on this side is negative 3. Perfect. And so let's take a look at a few more. What happens if instead of adding or subtracting inside, we add or subtract outside? So now what I'm going to do is I'm going to plug in a value for h, let's say 2. And I'm going to work it out and then pause the video and see if you can reverse it and solve for h. So if I have a 2 squared plus 25, first thing I'm going to do is power 2. 2 squared is 4. The next thing I'm going to do is I'm going to add the 25. So 29. So go ahead and pause the video and see if you can reverse this process and solve for h. Okay, let's see how we did. So the first thing that I see when I'm solving for h, or solving when I plug it in, is I've added 25. So my first step is going to be subtract 25. Cancel this out, and I'm going to be left with an h squared is 16. So far, that's on the farthest outside, and I'm doing good. I'm working my way towards the h. The next thing I did was I powered 2. I'm going to say, okay, the opposite of a power 2 is going to be a root 2, which is going to give me an h is equal to plus or minus 4. And I know with that plus or minus, it's going to give me two answers. H equals the positive 4 and h equals the negative 4. Boom. How'd you do? Oh, let's do 1 or 2 more. So the next one we're going to look at, again, let's assume some sort of value. Let's say y is equal to 3 and see where we get. So I would say 5 times 3 squared plus 10. I'd say my first step would be multiply by 5. So 5 times 3 is going to give me 15 squared plus 10. My next step would be power 2. It's going to give me 225 plus 10. And my last step would be add the 10, 235. Oh. Lo and behold, it looks like we accidentally found our value. I bet you in this case, y is going to be equal to 3. But again, regardless, let's go ahead and reverse it and see if we end up with our answer. Go ahead and pause the video, give it a shot yourself. Okay, let's see how you did. Now our first step, looking at the equation, I know that 10 is on the farthest outside, so I'm going to go ahead and subtract that, which is exactly what we would do if we're reversing our process. So I'd have a 5y squared is 225. I know my next step looking at the y is outside the set of parentheses is a square. So I'm going to square root, which is going to give me a 5y is equal to positive or negative 15, which again, I know that the opposite of a power 2 is a root 2. So far so good. But I do know that this is going to split my equation into 5y is positive 15 and 5y is negative 15. And looking at this equation, I know the only thing left is to isolate the variable by dividing by 5. Ignore that little thing right there, which is going to give me an y equals 3. I know the last thing over here is to isolate the variable by dividing by 5. So I get a y equals negative 3. And lo and behold, that divide by 5 step is actually the opposite of multiply by 5. So multiply by 5, divide by 5. Perfect. One more for good measure. We have two different values of adding. So again, I'm going to assume a value of, let's say, y is equal to 2. Plug it in. 2 plus 1 squared plus 4 is equal to 20. First, I'm going to add. So I'm going to add the 1. So that gives me a 3 squared plus 4. Next, I'm going to power 2. So 9 plus 4. And then I'm going to add the 4. So 13. So safe to say that 2 is not going to be my answer, but I have a roadmap of how I'm going to solve it. So let's check it out. My first step is subtract this 4 because what I'm looking at is getting outside this bubble. What that's going to do is give me a y plus 1 squared is equal to 196. Slowly work my way in towards the bubble. I'm going to have to undo this square power. I know I can do that with a square root, which is going to give me a y plus 1 is equal to plus or minus 14, which, as we know, y plus 1 is equal to positive 14, y plus 1 is equal to negative 14. And so far, we're check for check. Subtracted 4, rooted 2. I bet you my next step is subtract 1. Let's take a look. Yep, the only thing left attached to the y is subtract 1. Same over here. Cancel out, cancel out. So I'm left with a y equals 13. I'm left with a y equals negative 15. And so there we go. Anytime we're trying to isolate a variable, especially when it's nested with an exponent, try solving it and then just reversing your way back out, because that is how you're going to isolate the variable, is by getting to that point. And that's all.